Hello everyone, let me introduce myself. I am Facundo Carballo and today I will explain you all about Mutex. Since why we have to use Mutex, when we have to use it, and how to implement Mutex in our Golang programs. I want to tell you that all the code that you will see on this video, you will have it on my GitHub repo. You will find the link of this repo on the description of the video. I recommend you that you will have it close to you while you are seeing this video. It will help you to understand better all the things that I am explaining here. And after that, before we start with the video, I want to tell you that if you like this kind of videos, please hit the like button and subscribe to my channel, because with that you will help me a lot. So now I will let you with the video. Another synchronization mechanism that is very important to us is the Mutex. With Mutex, we can synchronize the access of multiple coroutines to the same resource, to the same variable. Let's look an example on this diagram. Here we have two examples, a without Mutex example and a with Mutex example. First, we will look this without Mutex example. So here we have two coroutines that wants to read and write this particular variable that is balance. So these two coroutines wants to access to the same resource, to the same variable that is balance. And the coroutine number 1 and the coroutine number 2 wants to do the same, that is read the balance, read the value of this particular variable, and then increment that value by 1. So imagine this situation like you can see here on the timeline, where these two coroutines are executed in this particular way, where the coroutine number 1 executes first, and well, this coroutine read the balance of this variable, and at that particular moment the value of this variable was 0, okay, and then well, the operating system quick that coroutine for any reason and put the coroutine number 2 to execute. So the coroutine number 2 at this particular moment reads the value of this balance variable, and well, at that particular moment the value of that variable was 0, and well, then ends and well, increment the value of that particular variable by 1. So at this moment the value of the balance variable is 1, but then the coroutine number 1 executes again, and well, this coroutine only left to increment the variable by 1. So like this coroutine reads at this moment that the balance variable has a value of 0, at this moment this coroutine will want to increment by 1, so will increment from 0 to 1 instead of what we expect, that is from 1 to 2, because at this moment the balance variable has a value of 1. But here the coroutine number 1 doesn't know that. This coroutine only knows that at this moment was 0, so the coroutine number 1 expects that at this particular moment the balance value is 0, 2, like in this moment. But other coroutine changed the value, and the coroutine number 1 doesn't know that. So with Mutex, we can synchronize that access to this particular variable. So we can be sure that when we read and write data, we are doing that in a safe way. So here we have this diagram where I try to show you how it will do the same but with Mutex, applying this particular synchronization mechanism that is Mutex. So here we have our two coroutines that wants to read the balance and then increment the value by 1, like we have it here, but here we are applying Mutex, this synchronization mechanism. So our two coroutines will have to ask to this Mutex, can access to that data, can access to that resource, and the Mutex is like a semaphore. We can get a green light or a red light. At the first time, the Mutex will be always on a green light. We can be able to access to this critical zone, that is this. But when a coroutine gets into that particular critical zone, the Mutex will be blocked. It's like the semaphore will put on the red lights. So if this coroutine, the coroutine number 1, access to that resource first, when try to get access to the same resource, it will be blocked because another coroutine is already using that particular resource, and we don't want to multiple coroutines use the same resource at the same time. So this coroutine, if the coroutine number 1 gets first, the coroutine number 2 will be blocked here, because this coroutine has the entire access to that particular variable. So this coroutine will have to wait that this coroutine ends to use this particular resource, and when this coroutine finishes to use this particular resource, here this coroutine will unlock the mutex. It's like we put the semaphore on the green light again, and we continue doing something else, but without using this particular resource. And then here, the other coroutines can be more than one, finally can access to this particular resource, because this mutex, at this moment, the mutex will be on green light again. And this coroutine can access to that particular resource and put the semaphore on the red light, so other coroutines can't access to that particular resource at the same moment. So to understand better this particular situation, we can see here this timeline. Like we have it here, well, but with mutex, always we'll look at this timeline. So here, first, imagine that the coroutine number 1 execute first, because the only thing that can change in this timeline is the order of the coroutines. If here is the coroutine number 1, well, can be the coroutine number 2. If here is the coroutine number 2, well, can be the coroutine number 1. So here, the coroutine number 1 execute first and lock the mutex. So put the mutex on the red light for the other coroutines. And read the balance of this particular variable and read 0, because at this moment the value of this variable is 0. Okay. Then the operating system quick that coroutine of executing and put the coroutine number 2 to execute. This coroutine try to lock the mutex, try to get access to this resource, but this coroutine cannot lock the mutex, cannot get access to that particular resource, because it's already blocked by another coroutine. So this coroutine will be blocked here until the mutex gets unlocked for the coroutine that lock the mutex. So then after that, the coroutine number 1 executes again, and well, like the coroutine number 1 already read the balance of that variable, this coroutine, the only thing that they have to do is increment that value that reads before by 1. So the coroutine number 1 increments the balance by 1, and then finally unlock the mutex. When this coroutine unlock the mutex, well, the coroutine number 2 will access to this particular balance variable and well, will read the balance and will read 1, because at this moment, when the coroutine number 1 ends, the balance of this variable will be 1, and well, this coroutine number 2 will increment from 1 to 2, and that's what we want. So now we will see this on code. I remind you that you will have all the code that you will see in this video in this particular GitHub repo. In this repo, I put all the code of all of the synchronization mechanisms that I am sharing with you in my YouTube videos. So I recommend you that you have it close to you while you are seeing my videos, because it will help you to understand better all the things that we are doing on the video. So now we will see this example in code. So here we have 3 functions: a do-work function, a with mutex function, and without mutex function. We want to emulate this particular situation, where we have multiple coroutines that wants to access to some variable and increment it by 1. And we want to do that using mutex and not using mutex to see the difference between these 2 implementations. So first, we will look the without mutex implementation. So this function, what it does is, well, creates a variable called balance and initialize that variable on 0. After that, we execute 10 coroutines that these coroutines will do this do-work function. This do-work function receives a pointer to this balance variable and then a flag, with mutex flag that, well, this flag will say to us, to this function, if wants to apply mutex or if not want to apply mutex. So for this particular case, we pass here false to not apply mutex, and well, we here dereference the pointer of this variable and increment it by 1 using this syntax, and then we wait for 1 second in the do work function. So we execute 10 coroutines that do this particular thing. So we expect that the balance variable at the end of this program, it's 10, because we execute 10 coroutines that all of one increment the balance by 1. So we expect that at the end of the program, the balance variable will be 10. But you will see on this code that not every time it's 10. The majority of the time it's 10, but in some situations it's not. And that's for the race conditions that we provoke here when we don't use Mutex or any synchronization mechanisms to handle that access of multiple coroutines to the same resource. So because of that, I want to show you that in some cases the variable balance will not be 10, I do this for end loop where I will repeat this process of execute 10 coroutines until I get finally a balance different from 10. And if this function gets a balance different from 10, well, we'll print that balance number on the console. And then we'll execute again. We'll try to find another case where the balance is different from 10, and again and again and again. It's a for end loop. So we will execute this. So here we have to wait until, well, here we have two examples now of that we are executing this function, but we are getting a balance difference from 10. In these two cases, we got 9 instead of 10, and that's for the race conditions. Here we have now 5 cases of race conditions in this particular execution of without Mutex. So you can see that if we don't apply synchronization mechanisms in some cases when we apply concurrency, it's dangerous, because if we execute this function once, maybe we get 10 as a result, and maybe we think it's okay, but it's not okay, because in some cases will not produce the same value, the same results, and it's dangerous. It's totally dangerous. So now we will see the implementation of this using Mutex, and then we'll execute the function with Mutex to see the difference between these two implementations. So the function with Mutex, it's the same that this function, but here, well, we just execute this once. We don't execute this forever, because forever will be the same results. The balance always will produce the balance tens, because always will produce the same results. The balance variable will have the value of 10. It will never get some different value of 10, because we are applying Mutex. With Mutex, we guarantee that. So here, well, we execute 10 coroutines using the same logic here, and the only difference is that here we pass the flag on true. So here in the do work function, we'll execute this part of the if statement, and here we'll apply Mutex. So it's like we see before on the diagram. When a coroutine get access to the Mutex, okay, we'll ask to the Mutex, can access to the resource, or I have to wait? If there is no coroutine using that particular resource, the Mutex will respond to the coroutine, no problem, came and use the resources, because none of those coroutines are using the same resource that you want to use, so came and use it. But if there is already a coroutine using the resource that we want to use, the Mutex will say to us, wait here until the other coroutines that are using this resource ends. Okay, I wait. So here, with this sentence, we ask to the Mutex, can I access to the Mutex? If the Mutex is already used by other coroutine, will be blocked here. But if it's not, if any coroutine are using this particular resource, we will be able to access to that particular resource, and well, for this moment, all the other coroutines will not be able to access to this particular resource, to this particular critical zone, because we already are inside of this critical zone. So the other coroutines will be waiting here until our coroutine that gets this resource, that lock this Mutex, doing the following, that is unlock the Mutex. When we unlock the Mutex, we'll put the mutex on the green light again, so other coroutines can be able to access to this particular resource. And that's all, because with this we are guaranteed that all the coroutines that wants to get access to this particular resource in a safe way. So now I will execute this function with mutex to show you that always we will get a result of 10. So I will execute this, and well, we get it here 10. I will execute this again, and well, we get 10 again. I will execute again to see what happens, but it will show me again 10, because always we will have the same results when we apply asynchronization mechanisms like mutex to this particular resource that all the coroutines want to access at the same time. So when we have to apply mutex, well, we have to apply mutex when we know that multiple coroutines will want to access to the same particular resource. If multiple coroutines want to access to the same particular resource in any time, it doesn't have to be at the same time or to do the same, because maybe we have another coroutine that do another work, another things with this variable of balance, but it's the same. If more than one coroutine get access to the same resource, we have to apply mutex. We have to, because if we don't apply mutex or some synchronization mechanism that allow us to be sure that when a coroutine get access to this particular resource, this resource will be safe from that moment until the moment that this coroutine ends or ends to use this particular resource. We have to be sure that, because if we don't be sure of that, we will not be sure about our programs, because our programs can produce race conditions or some other concurrency issues. So we have to be sure about that to don't provoke any of those concurrency issues. And well, that's all for this video. I hope that you could understand all about mutex. And well, again, I will tell you that if you like this kind of videos, please subscribe to my channel and hit the like button. It's free. Come on. See you on the next video.